Okay, hello everybody. This is Professor again in Power Electronics. We are in module number 3. Today we'll talk about AC voltage controller. After we completed, this is week number 10. After we completed rectifier circuit, converters and DC-DC converters, choppers and inverter, last circuit is the AC voltage controller. And we are going to discuss them as a single phase and then as a three phase. These circuits have many applications, wide application, especially in industry. We can use them for industrial heating, for transformer connection changing or light control, speed control of induction motors, and AC magnet control. Now, if I would like to classify them, I can say we can classify them into two main types: on-off control or phase angle control. We'll discuss these mainly, focus on these. Or if we did classify them based on the phases, it will be single phase or three phase. Or if we classify them on the control, if it is half control or full control, we can call them unidirectional or half wave control and full wave control. Now, the idea is very simple. We have here AC. Let's assume we are talking about Oman 230, 50 Hertz. Okay, 50 Hertz. This is volt, and this is my load, resistance or induction motor, whatever it is. I will connect two switches, semiconductor thyristor, let me say, anti-parallel. One to conduct the positive part and one to conduct the negative part. In the phase method, which is on-off control, what we will do, we will switch them to thyristors, definitely at angle theta, firing angle alpha 0. It's like diode now, but for a few cycles, and we don't trigger for another few cycle. Example. Now see, this is my input waveform sinusoidal. I will trigger for one cycle, two cycle. Then I will stop for one cycle. I don't trigger them, 0 output. Then I start again, 1, 2. You see? So number from here to here, number of cycle to be work and trigger, and M is the number of cycle which is off. When I come to integrate the output, definitely 1 over 2 pi is the full period. I multiply N over N plus M, because N is the number of on cycles, N plus M is the total number, N off and off, N on off. This is the integration. I got this formula. Have a look at this formula. Forget about VS. It seems to be the output voltage is related directly to N and M. How many, let me say, number of cycles my switch will work. Okay. Now let's take example. Let's take this as an example. An AC voltage controller, previous one, has a resistive load is given 10 ohm, and the root mean square value input voltage is 120. 60 Hz. The thyristor switch is on for 25 cycles and off for 75 cycles. He asked me to find the RMS output voltage. I have formula, the input power factor, and the average and RMS current of thyristor. I listed here my information given in the question. VSR, V maximum is square root 2 V RMS, and K, the constant between N to N plus M, I got it here. Now let's start from the output voltage. Output voltage is Vs square root of K. I have these values. I got 60 volt. Now if we divide by resistance according to Ohm's law, it gives me the current. V square over R or I square R give me the output power. To find the power factor, I need VA of the input. So VSIS. VS is the same, 120. And IS is the same I output. If we assume the circuit is lossless, I got the input power. Now let's divide output over input. We got the power factor 0.5, which is expected to be low power factor for this type of converters. Now, mainly this method used for induction heating or magnetic, because it produces heat, and we want heat from our application. I mean, if we use it to control motor, heat is not good for the motor. Okay, the other method to be discussed soon is better than this method. Okay. Now also I maximum, he asked me to find I maximum. I divide V maximum over R. I have it in the question. Then I come to find average and RMS for the thyristor current. Now definitely again N over N plus M by 2 pi. Integration from 0, we trigger at 0 into pi. We did the integration for sine and substitute everything given in the question, we got the current. The same formula here, just we square the input, the function, and taking square root for the function. We did it, okay, and we got also here the RMS current. The other method here is what we will do. First, let me start with half wave. So I have diode, anti-parallel with thyristor. The second issue, for this method, we control alpha. Alpha is not anymore 0, and there is no N and M. No on and off cycles. No, it will continue, but we control alpha. As you can see here, this is the input. I trigger at alpha here. Voltage appear across the load. Current also appear across the load. And here, diode will conduct the negative part. So this is slide here. This is the formula. I substituted. I got minus. Yeah, I expected because the diode will conduct the negative part and the full negative part of the waveform, while thyristor conduct part of the positive part. So definitely when we go to average it will be negative. If I divide it by the resistance, it gives me the current of the diode. Now what if we change the diode by 2 switches now? Now it's not